All right, then on slide 43, Chris Monckton deals with the so-called consensus lie, and that is the scientists really have a consensus that global warming is happening. And he referenced a study done by Schulte in 2008, which did a search of global climate change from the beginning of 2004 to the beginning of 2007 and came up with 539 papers. Amongst them, the ones that showed evidence for a catastrophe, 0. So let's investigate this in more detail. So Chris Monckton indicated, and if you listen to the audio, he said he was boring, so he checked, and he reviewed a published work on the consensus of climate change. And the published work used the terms global climate change, 2004 to 2007, and found 539 citations, and none of which provided, quote, any evidence at all of any catastrophe arising from any anthropogenic effect on any part of the climate in any part of the world. So the inference Chris Monckton is giving here is that there really isn't a scientific consensus on climate change. Not only that, scientists aren't even publishing work that shows that there's some looming catastrophe. So if the scientists don't have a consensus, and if they don't even think this is potentially catastrophic, why should we care? That's the inference. So what we want to do is we want to do our own investigation. And so I'm going to show you a technique to check for yourself, and you can see whether the inference Chris Monckton gives accurately reflects the understanding of the scientific community. So what I want to do is provide people with a vehicle to do their own search and see if the inference Chris Monckton gave is reasonable. And that inference is that a search of the scientific literature shows no papers which show evidence of catastrophe, and if the scientists aren't concerned that there's a catastrophe looming, then why should we be concerned? That's the inference I'm working under, and if that inference is incorrect, I am happy to stand corrected. My goal is to show people how they can learn about the scientific understanding on their own. The way to do that is very easily go to Google, and once you're on Google, you can click the More button and you can select Google Scholar. That allows you to search scientific papers and conferences, etc. You can use the Advanced Scholar search, as I've shown here, and you can type in a very clearly delineated search terms, and I'm using the words that Chris Monckton used, global climate change, and I'm using 2004 to 2007. Now my search terms includes both 2004 and 2007. Chris Monckton truly said from the beginning of 2004 to the beginning of 2007. So I may be including some papers which he did not have in his search. And with that recognized, let's see what we find. So what else do we find? Here's a paper published in 2004 which dealt with accumulating evidence of global climate as a result of human activities. Here's extinction risks due to climate change. I'd call that catastrophic. Here's a paper on infectious diseases and another one on ocean acidification. So when you consider this stuff, I mean, scientists are concerned. There really is a problem with global warming. And I think that really contradicts the inference Chris Monckton gave. We'll just do a couple more. I don't want to dwell too much on this because people will see the volume of papers dealing with problems related to global climate change. But here are a couple more, right in order: regional vegetation die-off and drought severity index increasing. And then this one deals with sea level rise. So you see that scientists really are concerned about this, and the idea that a search of global climate change doesn't show a catastrophe concern is really off base. Next, just over 53 minutes into his presentation, Christopher Monckton discussed a paper by Mourner, 2004. It's a paper which certainly exists, and that paper showed there's no sea level rise in the Maldives, which is an area of concern. It's a low-level island, and so there's concern about sea level rise for the inhabitants of the island. So what do people say about this work? Well, here's a paper from 2006. It was published, and they explicitly looked at the Mourner study, and they did not conclude the same way Mourner did. Quote taken right from that paper. Here's a screenshot of the paper, and you can see the abstract with the relevant text highlighted. What about other researchers? Here's a 2005 paper, again dealing with sea level rise and the Maldives. And here is a screenshot of that publication. So if you go to some of the major organizations like CSIRO out of Australia, here's what they say about sea level rise. If you look at global mean sea level, It's rising pretty continuous. And again, just like with temperatures, there are some ups and downs year to year. But if you look at the long-term trend, that sea level rise is proceeding quite continuously. And they've got two measurement methods. One is satellite altimetry. The other one is tidal gauge. And you can see that those are mutually reinforcing. Sea level rises are occurring, and that's pretty clearly indicated by the science. Now, Christopher Monckton, in about 55 minutes into his talk, talked about how temperature changes first and CO2 follows. Let's look at what scientists say about this. Here's a paper from 2003, which dealt with recent anthropogenic CO2 increases, and they talk about CO2 being an amplifier of initial orbital forcing. The issue here is, in the past, there weren't humans around to cause CO2 emissions increases. So why were there climate changes in the past? Well, due to many other factors, primarily orbital forcings, that is related to the orbit of the Earth around the Sun and the tilt of the Earth in what's called the precession. But what scientists believe is that CO2 has responded to that, and it really kickstarts climate change and amplifies it. And that's what's indicated by this publication from 2003, and here are screenshots. And in fact, you'll notice here on the left it says, finally, the situation at Terminal 3 is differs from recent anthropogenic CO2 increases. So just because CO2 changed second in the past doesn't mean that it wasn't heavily involved in climate change. And in fact, if you consider that CO2 is one of the strongest, perhaps the strongest indicator of temperature changes, are you able to calculate temperature changes? Well, here's a 2007 paper by James Hansen, and they used paleoclimate to provide a sensitivity of the climate to CO2 levels. And they put that into a model, and here are their calculations, and this graph shows how they agree with observations. Really clear indication that temperature and carbon dioxide are closely matched. You don't get temperature rises without CO2 increases, and vice versa. So this clearly shows that CO2 level is a very strong driver on climate, both today and in the past. So next, Chris Monckton takes a passage back in time, and he talks about how for 600 million years it was warmer than it is today. Well, that may be true, but guess what? That doesn't mean we want to go back to a time period that's 7 degrees warmer than today. I mean, our society and places we live and how we've developed the world have occurred in the environment in which we're in now. Do we really want to go back to a time period where sea levels were much higher than they are today or much lower? I don't think so. And what paleoclimate shows is that things such as sea level are really sensitive to temperature. I mean, the glacial periods have temperatures that are maybe 4, 5, or 6 Celsius colder than they are today, and that gives continual ice sheets in Minneapolis year-round. Do we want to go back to that kind of situation? I don't think so. So just because temperatures were hotter in the past doesn't mean that current warming is not a problem. And on this slide 51, Monckton refers to a 1999 paper talking about interglacials being warmer than they are in the present. And again, the argument is, hey, if it's warmer then and the Earth survived, why do we care about temperatures now? So we can actually go to that paper, and I've got a quote here, and the paper was published in Nature 1999. And the relevant text is highlighted. In fact, on the left, they say, present-day atmospheric burdens of these two important greenhouse gases seem to have been unprecedented during the past 420,000 years. And on the right, finally, they're strongly correlated with Antarctic temperatures. And this supports the idea that greenhouse gases have contributed significantly to glacial and interglacial change, and the correlation together with uniquely elevated concentrations of these gases today is relevant for our future climate. And these authors are clearly concerned about modern-day greenhouse gas levels. One of the things mentioned by Chris Monckton was that scientists have overstated the threat of ocean acidification. He gave the inference that ocean acidification is not a concern. So what do the experts say about this? Well, here are two full citations with URL links so people can access them themselves. In the first one, published in Science 2007, it clearly states, under conditions expected in the 21st century, global warming and ocean acidification will compromise carbonate accretion, with corals becoming increasingly rare. The second paper, 2008, from the Journal of Marine Science, says ocean uptake of carbon dioxide is altering seawater chemistry. And they mention anthropogenic. That just means man-made or human-caused carbon dioxide. And let's go on and see what other people have to say. And we can continue. Here's a paper, 2008, talking about ocean acidification representing a key threat. And here's another paper recently published last year, 2009, talking about ocean acidification and pH. And then one more slide. Here's a 2008 paper talking about ocean acidification and another 2008 paper. And these are just a representative sample. There's a lot of papers which talk about ocean acidification. It's a big issue. Scientists are really, really concerned about ocean acidification. And Chris Monckton has made the point in other venues that ocean acidification is not a problem, and that even if it were a problem, ocean weathering of flowing of water over alkaline rocks can really mitigate ocean acidification, and the scientists who study this area don't agree with him. So the question is, what does he know that they don't know? I think I'd place my bets with the folks who really study oceanic chemistry. On his slide 56, Chris Monckton showed a graph. This is the graph actually taken directly from a slide from the IARC JAXA. That's a collaborative research effort between two institutions, one's in Alaska. And he shows Arctic sea ice extent variations on an annual basis. And so you see these up and down curves as the ice increases in the winter and then it decreases in the summer, which is what you'd expect. And the inference he's given is, hey, you know what? The sea ice goes up and down and there really isn't a concern. And in fact, the title of his slide says, Arctic sea ice is just fine. It's been steady for a decade. So the question is he right? Is he interpreting the data right? So is Arctic sea ice just fine? And are reductions in Arctic sea ice having nothing to do with global warming? Well, let's go look at the center he took his data from. That's the ARC. And here's what John Walsh said to me. He's a ARC research scientist. Our findings provide a physical basis for extreme summer losses of ice in recent years. So Dr. Walsh referred me to the NSIDC. Let's go check out that organization. It's the National Snow and Ice Data Center. And they show a graph. This is available right on their first page. Here's the link, and they look at graph on a year-to-year basis. So this is from 1979 to 2010. And you see that on a year-to-year average, there may be some ups and some downs, but the general trend shown by the blue line is downwards, and very clearly downwards. What's interesting is if you go to that website, you're going to find the following quote. The rate of decline through the month of May, and that's May 2010, was the fastest in the satellite record. By the end of the month, the extent fell near the level recorded in 2006, and it's the lowest in the satellite record for the end of May. So that's a pretty clear indication that Arctic sea ice is decreasing.